Jean-Baptiste, Vincey, and I'm an Android engineer at Deezer. And I'll talk to you today about design system. So, first small thing about Deezer. So, actually, you might have seen that in all Berlin, but Deezer is not really about bikes. It has very little to do with bikes, actually. And Deezer is all about music. So, just so you can, so you know. So actually Deezer exists for more than 12 years now, and the mobile apps are more than 10 years old, and we still work on the same base code. Also, just to give you some context about like why we decided to create and to build a design system. Also, we don't have only one app, but we're also developing different side apps. So we have, for example, the radio app that is launched in several countries in Europe, and we're currently building a Sony 360 app in partnership with Sony. So one of the main challenges we have nowadays is to make our user interface evolve while keeping consistency and like not reinventing the wheel every time. And I'm sure you all face this kind of issues. So let's say that I'm new to Deezer and I have to create a new feature, a new screen, and I receive a mockup from designer, and I have to display a list of tracks, sorry, in cells. Okay, so how do I know where to look for the cell in the component? So is the component already existing or not? Should I search myself in the app, like search in the app to find something that looks like this? Or should I search myself in the code? In the code, there is little chance for me to find it. And what if I find a component that looks like, but it is a bit different? What should I do? So does that mean that I should update the existing component, and so these changes should be applied also to every screens in the app? Or should I fork the existing component, or should I create a new state inside the existing component? So this is the kind of issues we face every day. And so as you can see, we might, there is the risk that we lose consistency over time inside the app itself, like inside the Android app, but also across platforms, like between the Android, iOS, web app, and among the different apps, for example, the main Deezer app and the radio app. So to tackle these issues, we decided to build a design system. Okay, so let's first see what is a design system. So basically, we consider that design systems are composed of three things. So first is a style guide. Basically, it defines the colors, the text styles. Usually it's brand related. And that is what makes, that defines the look and feel of your app, basically. The second part of design system is a component library, where you define all your UI components, and the last part is a set of guidelines. So the very main idea behind design system is that we should stop to consider apps as a set of pages and screens, but rather as a set of functional UI components that are composing different pages. Okay. So now how do we build such a design system? So we got actually, at Deezer, we got inspiration from Brad Frost, who wrote a methodology that he called atomic design to build a robust design system. And so Brad Frost got inspiration from chemistry, so more specifically the science of matter, to organize and to propose a hierarchical organization to divide the UI components. So let's dive into it. So the different layers that compose the atomic designs are atoms, molecules, organisms, templates, and pages. So you can see that for the last stages, he came back to a more usual a comparison that is more about publishing with the templates and pages. So what is an atom? So atom is the very most basic building blocks of your user interface that cannot be broken down into smaller pieces. So here you can see some examples. So here you have, for example, some cover picture, a title, a play button, a subtitle, a label, and so on. Then molecules are basically composed of several atoms and form a functional unit. So you have all the atoms we saw just before are stacked together to bring this molecule that represent an album card. Okay, so the molecules are more complex, but they should be kept rather simple in order to be really easily reusable. So now organisms are more complex components that are usually composed of both atoms and molecules, and they generally represent an entire section of a page. So here, for example, we have an horizontal carousel representing the discography of an artist. And as you can see, it's composed of different molecules that are the album cards we saw just before. Now, the template is really a blueprint of the interface organization for a screen. So it defines the position of each complex building block you have, so typically organisms in your interface. And so here you have an example with a simplified organization for an artist page with a header, a carousel for the discography, and a carousel for the similar artists. And finally, you have the pages are actual instances of templates that bring real data and real visuals. So that will look like the end screen as the user will see it. So now how to build such design system in practice. So the first thing we did at Deezer is choose our own vocabulary because we were not so comfortable with the atomic metaphor. So we chose our own, which is about Lego, and that is really centered about the concept of bricks that you can stack up together to build more and more complex components. And actually, the Lego metaphor is quite used very often in the UI and UX area, and is also used by Brad Frost himself in his talk, in his book about atomic design. Then we set up our component library, so that we chose to call UIKit. This is just a name that we chose for that. And what is really important to understand is that it exists both for designers and for developers. So we have the component library for the design part on the one hand, and usually it's now always possible to build such library, component library, with the tools that we use nowadays to create mockups and that the designers usually use. So for example, with Sketch it's possible. Now we are moving, at Deezer we are moving to Figma, that is also another tool. But even with Photoshop or whatever tool you usually use, or designers use, they now have plugins to create a component library where they can really reuse the component in the mockups that they create. And on the other side, we have our own Android implementation of this UIKit, and so this is based on an Android library. So it has its own repo, and this is important in order to be reusable in different apps. Also, this Android library has its own application that we called it the Playground. This is actually a showcase that displays every UI component of the UIKit. And this is very, very convenient for 3 reasons. First is that you can see every UI component of your design system in just a blink with this app, with this playground. And this is very important for design reviews with designers, QA, product owners, etc. The second thing is that it makes also a lot easier to develop new UI components, since it is really much, much lighter than the main Deezer app. So it's really fast to compile. And so it makes it, yes, much faster to build and to create new UI components. And lastly, it enforces a good architecture with a good separation of concern. Since this is in a separate repository, in a separate project, there is no dependency with any business logic. So this is only about UI. And so there is no way you can mix your code around. So this really separates things in a good way. So next step is to define the style guide in our UIKit. So as we said earlier, this is to define the colors, the text styles. And what is really important is that all these colors and text styles should be named, and named in the same way for designers and developers. So that is the only way to clearly identify UI components and to be able to make them evolve and to maintain them. Then we're coming to really the UIKit implementation. So this is the implementation we chose at Deezer. So it is based on a recycler view. So basically, almost every page in Deezer app is based on a recycler view, and every UI component, more or less, is a brick, as we said earlier with the Lego metaphor. And we have our own implementation of Lego adapter that can handle any combination of brick. So it handles the brick display, the views updates, also leveraging and using the diff util to update only views when required. And it handles recycling and animation. So now, in order to build these bricks, we have first to set up atoms. So what represents an atom in our organization? So an atom is basically composed of either an Android widget or a custom widget. So here, that would be a text view with associated with a specific style. So here, this is a text style that is called H3 that was defined in the style guide. So it defined the text size and the text style. Now about molecule. So molecule is now clearly a brick. So what is a brick in our system? It is actually kind of a model for the view that embed all the data that would be displayed in the UI component. So here we have a very simple artist card that has an image and a title. And so in the card brick, so this is just a model that that has a title, a picture URL, and an ID that will be used by the Lego adapter for the diff util computation. It also implements a few methods that are part of base brick that are required for the Lego adapter to be able to handle and to display every brick. Okay, so our molecules are based on that data binding in order to bind the data to the view. And here you can see the layout for the molecule. So you can clearly see how the molecule is composed of the different atoms, with here the text view with its own style, and the image view with also a specific style. And finally, an organisms. So an organism is basically also a brick, but that acts as a brick wrapper. So that means that it also it receives as data a list of bricks. For example, here we have a carousel brick that will be based on an horizontal carousel, on a horizontal recycler view, sorry. And it will receive so a list of base bricks that will actually correspond to the list of artist cards here. And so in the end, we will have an architecture that looks like this. So this is based on MVVM architecture. So we will fetch the data from a repository. So we have our raw data, for example, an artist, whatever. So we have it in our view model, and the view model will have a transformer that transforms our raw data into a list of bricks. And this list of bricks is passed through the activity into the Lego adapter that will handle the display. Okay, so here, all you need to do in order to create a feature, a screen, when you already have all bricks defined, is only to create your view model, to fetch your data, and to create your transformer that transforms your data into bricks. And so it is really simple. So a transformer for the artist page will look like this. So here you see that I receive an artist, and I just create two carousels, so one for the discography and one for the similar artist. And so I create that based on sub-transformer for types. So for example, here I have an album transformer and an artist transformer. And this will just look something like this. So my artist brick transformer just create a carousel based on the data it receives. So here the list of artists. So you see that it makes it really extremely simple to create new features and new screens once you already have every brick defined. And this is kind of the magic and the power of this architecture. Okay, so in the end, it has, so this organization and this design system has many benefits. So it ensures consistency by enforcing reusability of components in different levels. So even so the different atoms are reused in molecules that are reused in the organism, etc. It's ready to use in different apps when you define your design system. So in our Android library, so it makes it really very easy to create new apps based on that. And so we keep the consistency with the first apps. It's really easy to maintain and extend, and it supports design evolution in the sense that every UI component is very clearly defined with its own name, and it's defined exactly the same way between designers and developers, so that we can make this UI component evolve in a systematic manner. And finally, and that is one of the most important parts in design system, is that it really strengthens collaboration between designers and developers, because now we really work in the same way. We divide the components into several layers exactly in the same way. We identify, we name our components exactly in the same way. So in the end, we really work exactly in the same way. So to sum up, what we saw today is, what is it? A design system based on style guide, component library, and guidelines. We had an overview of what the atomic design is in order to build a design system, and we saw how we did set up our design system at Deezer for you to get some good inspiration to build your own. So we chose our own vocabulary, we set up a style guide, we set up a component library, so that we called the UIKit, and we proposed an implementation based on Recycler View and a Lego adapter. And so there are some websites, some articles that you can check out, and I really recommend the first one, that is actually the blog, the post from Brad Frost about atomic design. And so if you are really interested in atomic design, this is really a must-have. And that's it. I think we have maybe 1 minute for question. Otherwise, you can just come to see me directly.